Yeah. Oh, good thing to note, Simon, about invariance. Yeah.
There was a specializing overloaded function.
Yes.
And what does that mean? Or does that mean you're specializing some kind of, say, EQ int?
Yes. Yes, it does. So if you've got
the dictionary.
So the specializing stuff is in compiler, specialize/specialized.lhs. And there's quite a lot of comments in there, actually, that explain quite a bit about how it works. But I'll just briefly sketch what it means. So if you've got a function type num a to a, then by the time it gets into the core language, it's going to look like this. So it binds the, first we bind the a, then the dictionary here, that's this guy, and now here's the argument. And now if we were to do addition, we would now, if it was originally f of x equals x plus x, then we're going to say something like here, apply the plus operator to d and x. And what this means is, take this record, pick out, this plus simply selects from a field, so plus of that colon num underscore 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 p underscore 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 equals p. So this is the dictionary for num, plus simply picks out one field and returns it. Right, that's all that overloaded things do, is they take the dictionary and they pick the method out. So this is what f will look like. But this is not, so this plus is nothing only about numbers, it's just a selector. So if you are actually applying f in this module only int, so if you see f applied to int and some dictionary d int and p and q, I don't know, just p, somewhere else in your module, then you might say, oh, well, so this thing f at int and d int, if I was to specialize this for knowing that alpha is int and d is d int, then I could do the selection up front, because I know that selecting plus from this d int field will be the plus int on integers. And then I get much more efficient code. Does that make sense?
Yes, so you're just, it means it's not just doing for the primitive class. So they're, like when you define your own class for
yes. This will work perfectly well for some arbitrary class C, yes, for your own class. So you might say, how does it know which? So effectively, you're going to take a copy of the code for f and specialize it, actually simply by applying it. It just takes the right-hand side, f equals right-hand side, and it's going to make f spec 1 is the right-hand side applied to int and d int. That's pretty much all that happens. So it's just make a copy of the right-hand side and applies it, because that will and so how does it know what to do? Well, it looks in the module and looks at calls of f in this module, but it can't see calls of f in other modules. So in that case, you have to supply a specialized pragma. Say like this, specialize. This is documented in the user manual. F at type t to t, and then it'll run off and make a specialized copy there. Yes, Ivan.
Special case of this optimization we mentioned just before, where you're essentially calling the function with a non-constructor.
Yeah, it is. So, and in fact, the specialized constructor thing that I was describing is in the same directory. You know, it's also specialized, but GXC treats this a bit differently, because every call to two calls to f might not specify the same dictionary. Exactly the same dictionary argument. Right? There might be, well, in case of d int, it probably would, but in principle, you could see this. Right? Where these two were not the same. Especially if it was, if this was perhaps not int, but list of int. It might be a constructed dictionary. It might be constructed twice, and you have a common sub-expression of it. Right? But in fact, because they're of the same type, we know that, oh, these two must be the same, because there's only one dictionary in any particular type. So in effect, it takes takes advantage of a bit more specialized stuff just to do with overloading. And I wrote it first, but it'd be quite an interesting thing to see whether you could combine these two. Yeah.
I'm still a little confused about this. When would you not be able to specialize
An overloaded function. Will you not be able to specialize this guy?
Specialized overloaded functions.
Oh, well, if you don't have optimization on, we don't do specialization.
Oh, I see.
And also, if there are no calls to F in this module, if there's just the definition, it wouldn't know which types to specialize at.
Oh, okay.
Right.
So there's no actual call that will be unspecialized of an overload function.
Is there any call that would be unspecializable? Actually, yes, there is. They're getting at this. So if that's like the definition of F, then I've seen definitions go like this: G equals big lambda beta, bubble, bubble, bubble. And in here, I got something like F at list of beta and some dictionary, blub. Right? Now, at the moment, so the dictionary here is going to involve beta, num beta or something. So at the moment, so the right place to make the specialized copy of F, if you were going to do it, would be to put the copy of F right here. But at the moment, the specialized pass doesn't do that. It will only generate specialized copies with the original definition of F. And so when it comes across this, it just says, oh, I can't specialize at that time. So
there's nothing, there aren't any calls that are in principle unspecialized?
No, there's no calls that are in principle, that are not specializable in principle, yes. And one of the good things about this architecture, incidentally, is that the core-to-core classes are one place where you really can add a pass here, and provided it takes core and generates core, a pass can be as small as 30 or 40 lines, right? Because the core type is very small. If you want to do something a bit more elaborate, it might be a bit longer, but your responsibilities are very clearly defined and they're quite limited. So if you're wanting to play with adding optimizations or transformations or analyses, this is a good place to play, because your responsibilities are limited and the data types are small. So just responding to you, maybe you could do something, do a better specializer and plug it in instead and measure how much better it was.